field robotics, agricultural robotics, and autonomous systems. And finally, we have Mr. Saurav Shandilia, also an ex-e-Yantra team member. He is currently a senior software engineer at MathWorks, working on embedded systems and code generation. He has previously worked at Bosch, holding multiple patents, and has published in IEEE. His interests include embedded systems, IoT, real-time software, signal processing, computer visions, and machine learning. Let's welcome all our judges. Okay, let the show begin.
So, good morning, all of you. So, we just go over the things of the team and we start to get an idea of the party, name of the team, and what are the learning. So, basically, the team has its name to Krishi Cobot. So, here you have mobile robot, and that is the eYRC robotic arm. Both are collaboratively doing the task. Or this is a smart game, mimicking all the data. The task is that the mobile robot will navigate through all the lanes. So basically it will start from this point. It will navigate, goes towards the top stage. So you can see the vector and shape there, blue color. So it needs to stop there. The robotic arm needs to pick the fertilizer and load it on the keyboard, the mobile robot. So basically the fertilizer will be loaded on the robot and the robot task is to monitor the plant. So you can see some shapes on the plant, right? There is a triangle and there is a square. Basically the triangle denotes that the plant needs fertilizer and the square denotes that the plant is in critical battle. So the aim is for the keyboard, the mobile robot has a LiDAR and they have to detect that feature using the LiDAR. They have to stop this and basically they will publish the detection and you will hear an audio and also an LED light. Meanwhile, while the robot is moving, the robotic arm needs to sort the fruits placed on the tray. You can see the fruit placed on the tray. So there are two types of fruits. One is the purple color one, which is the good fruit, and the grey ones are the bad fruit. So the aim is to identify the first you need to detect the fruit. So here you can see the camera there. So you see the camera has bad fruit, and the arm needs to pick and place it in the bad fruit. So this happens while the bot is navigating around, and after the bot does its task, it will come back to the dock station and it needs to unload the fertilizer. So the can which was placed, it will pick it and again throw it in the trash can. So this is the whole overview of the thing. So yeah. Can you? Yeah. Hello. So the major learnings for this team are the main operating system, the main stack which we are using is robot operating system here. Then the concept for the mobile robot is autonomous navigation. So the students have to make an algorithm to navigate the e-bot autonomously throughout all the lanes while performing the detection part. Then there is arm manipulation for the eYRC arm. They need to plan the path. They need to also pick and place both the fruits and fertilizer. Then so basically there are two stages. In stage one, the students participated in a simulation environment. So for 3 months, around 3 months, all the work was done in Gazebo, and the top teams were then selected to work on the hardware remotely. So this team is a remote hardware team. So basically, till the task 6, they were working remotely through a web portal. So they would access all the hardware through the portal in a stipulated time of 1 hour. So after the finalists, now they have come here and in the 3-4 days they have tried the algorithm in the real hardware here physically. So till before this time they have all worked from their own remote locations. And computer vision, this is the main thing they are using for all the detection tasks and also the shape detection using the LiDAR. Then Git is the basic version control system they are using. So the tools again is ROS2, this is Gazebo, OpenCV for the computer vision tasks, and Python for all the scripts. So all the scripts have been written in Python. Okay, now we'll look at the environment. So as you can see, it's the same arena here. So this is the mobile robot. These are the plants, and yeah, I guess I have told almost about everything. This is the arm, fruits. Okay, this shape is the dog station, and this is the bad health detection status, and this is the fertilizer required. So you can see this is the config for the final. So this will be kept same for all the teams. So this is the config, the same thing which is here, and there is a certain config for the fruits also. So this is the arrangement for the bad fruits, the grey ones. Okay, now I will play the theme film. Yeah, so we will move to the scoring parameters required. So there are two parameters. One is the internal scoring, which will be done by the team, and the just scoring, which you have to do. So basically, we have given you the sheet with 4 parameters. So I will just. So this is the internal parameter just for the reference. So these are the various parameters here. T is the total time. So for BRAT, the fruit identification, we have this parameter CBI. For the pick and drop, we have CBD for the bad fruits. The fertilizer can, for identification, we have this parameter CFI. For loading onto the robot, we have CFL. And for final unloading, we have CFU. For the plant detection, we have CPD. And for each lane navigation, we have CLN. B is the bonus if they do all the tasks correctly and return back to the home position. Then we have collision penalty. So if they collide anywhere in the environment, they get a penalty. And there is a false detection penalty. So if they detect it in a false manner, they will get a penalty for that also, for the shapes. Also, the condition for a valid run is that it's only when the team loads the fertilizer onto the e-bot. So if they miss the loading, the run will be considered invalid. And also they should detect at least one fruit correctly. So both of these conditions should be satisfied simultaneously. Now we'll come to the judges scoring. So the judges scoring has 4 parameters here. and 4 topics on which you can ask the questions to the participants. So we have image processing, then arm manipulation, which is for the arm, then autonomous navigation, and LiDAR based shape detection. So the questions can be based on the algorithm they have used or the design of their basically the system, the whole integration. Like it can be crossing this. Basically, you can ask questions beyond this, but this is the brief overview of the topics which the questions can be asked. Yeah, so basically how what algorithm they have used for the navigation. Okay, so we'll see the theme developers for this theme. So Goresh Wadekar, who is the theme lead, then myself Tasim Khan, then we have Joel Davis here, and special thanks to Jason, Siddharth, Ajay, Madhu, Kamudi ma'am, Riddhi ma'am and Anuj sir for the video and photo work. So this project is supported by the Ministry of Education, Government of India, all the funding. Then our principal investigator, Professor Shivaram Kalyani Krishnan. And the team e-Yantra which help us make this event possible today. And finally our founder, Professor Kavi Arya. Okay, now let's begin with the final. Okay, let the show begin now. So the first team which is going to do the run is team ID 1550.
Tell them when to start the game.
Okay.
Just tell.
हमारा ग्रेडर में टाइम है.
Announce करता whenever the ball will time starts.
Okay, so the timer will start whenever the robot moves, any of the robots. So if the arm moves, the timer will start at that time, or when the mobile robot moves, the timer starts at that time. जो पहले मूव किया.
So, hi Professor. Hello. Hello. Yeah. So, hi Professors. Hi guys. So we are team 1550. We are from MAG College of Engineering and Bangalore. Yes.
I didn't notice you that you were sitting next.
So right now what is happening is that the bot is moving towards the arm. Hello. Okay. So right now what is happening is that bot is moving towards the arm, and it stopped near the pentagon where it is waiting for the fertilizer to get loaded. Now the arm is moving towards the fertilizer to pick up. So as we see, the end effector of the arm has attached the fertilizer to it, and it's dropping. It's going near to the e-bot to drop the fertilizer can on the e-bot. So once the fertilizer can has been dropped, the e-bot started navigating towards the lane, and the arm is moving towards into the bad fruit to pick up. Now the e-bot mic बंद क्यों हो रहा है यार? Now the e-bot is moving into the second lane. Now the e-bot is navigating. So listen, sir. Sir, the mic battery is low. Battery is low.
This plant is in bad condition.
Offset. So basically, ARM had to go near the fertilizer as the bot came. So we wanted to pick up. So right now, what happened is that ARM went offset. Like it had some offset. It was off the can. So, yeah, it is like sometimes it affects the lighting also, but again, it's more towards the algorithm. I mean, the way we are approaching to.
Your algorithm is not robust enough.
So it is, but the thing we have to make it a bit twin. Tuning is needed.
So when you ran this theme in from your college, you ran it online here.
Yes, sir.
Out of 10 times, how many times did it work?
So it was almost working. So
Almost means what?
like the arm could able to pick up the fertilizer,
Out of
then
10
also
times, how
drop.
many times did it work?
Stroke is there. So if it is still
No, simple question. Out of 10 times, how many times were you successful?
So 8.
earlier we have some issue when we came here. Earlier it was
Simple question.
Yes.
10 times where, how many times did it work? 9
Nine
times.
to eight
He's saying
times,
8, which is more honest, I feel.
Nine
Right?
times.
Huh? So this is that 9th or 10th time and it's not working basically. Right? So I feel students don't understand that if it works, it should work 10 out of 10 times.
Yes, sir.
Otherwise it's not working.
Yes, sir.
So I think you have another run.
Yes.
Yes, sir. One more run we have.
I think it's a very standard problem that we have been seeing from 15 years.
Currently the first run has completed and in this run they had
Yes.
6 contacts and they have already utilized.
सुनता नहीं है क्या मेरा आंसर? क्वेश्चन सुनता नहीं है क्या? तो क्या पूछा? कोई बात नहीं, वो नहीं पूछा। जब तुम्हारा रन करते हो ना, तो जब तुम कर रहे थे रिमोटली, तो 10 आउट ऑफ में कितने टाइम तुम्हारा रन हो रहा था? नहीं, पूरा नेविगेशन पूछा था।
Meditation needs to be done at times of
Mic.
So that was the first run. Now they will have one more run 2. So the timer will start when either the arm or the robot moves. So the timer has started. So you can see the bot has started navigating and it's entering the first lane. So now it's stopped at a dock station and the arm has started to go towards the fertilizer can. So the arm has attached to the fertilizer successfully. The team has loaded the fertilizer successfully.
So now guys are saying from army we have one instance like this, different field based basically we do this for results.
They have completed the lane 1 travel, sir, and they are entering the lane 2 now. They try to pick the fruit, but now the e-bot is entering the lane 2.
This plant needs fertilizer.
They have done one fertilizer detection.
This plant needs fertilizer.
So this is a detection penalty because they have detected it twice. They have successfully picked one bad fruit. Now the bot is entering into lane 3. Yeah, they have missed the 2 detections of the triangle. They have picked one more fruit. Technique here. They have dropped the second fruit and the bot is heading back towards the dock station. Now the bot has stopped at the dock station and the arm will try to unload the fertilizer. Stop the timer. So the team was unable to unload the fertilizer and the run ends now. So the time for the run was 3 minutes 43 seconds.
I thought it detected red one first. Can you say which is an extreme?
98.
1798. You can do it. We do fast detection, right? Shape detection and correct detection, or both are fine.
See that you can't do variable shape.
Good to start. Okay, maybe to start off, just if you could explain in your own words what worked well and what didn't.
Yes, sir. So first off, our navigation worked well. We didn't have any collisions. As for the fruit pickups, what happened is out of the 3 fruits in our second run, the third fruit, the first fruit when we went for, when we approached the first bad fruit, the magnet didn't stick strong enough to the bad fruit. So when it lifted it up, it basically dropped off. The other 2 had a good enough contact with the fruits. So because of that, we were able to do a successful drop off. In terms of the fertilizer drop off, so what we assume went wrong is the check or the lookup we were doing for the Aruko marker was being a bit too early, so before the bot stopped. So it was going to a position where the bot previously was and not where the bot was currently at. So due to which the arm was a bit far off, not picking up at the correct place. And in terms of shape detection, we were detecting the shapes, the bot was stopping it, but we made the bot stop and wait for the odometry to stabilize. Only if the odometry stabilized, it was supposed to publish. And turns out our tolerances might have been a bit too tight, so the odometry did not stabilize
as much as we wanted, because of which most of the publications didn't have it.
Okay, then maybe I'll go through a few of the specifics. So on the image processing, so this I believe is used for fruit detection, right?
Yes, sir.
Is that the only place where?
We were also using image processing to detect the Aruka markers and find out their position.
I see. So for the first round, I don't remember exactly when it was trying to pick up the fruit, the arm didn't exactly align on top, right? So what are the reasons for this?
Yes, sir. The transforms. So what we are basically doing is we're using the depth values that we are getting from depth sensing camera. Usually what happens is the transforms from that can be off by 3 to 5 centimeters.
Okay.
Sometimes the transforms were not generated exactly in the middle of the fruit. It was a bit off, so the arm was trying to approach that specific position.
So can you think of some method to solve this? Like you know that it will be off, it will have certain error. What is a systematic way of dealing with that error?
I mean, if there is if all the fruits are having the same amount of offset, you could like manually add like for example, fruits were having 3 centimeter offset from the actual center of the fruit. We could just have a 3 centimeter offset which corrected it. So, we were also trying an approach where we could calculate the center of the circle and approach that. Unfortunately, that didn't work out for me.
I mean, yeah, assuming you know the offset is probably not a good idea because you won't know. How about some kind of a feedback mechanism where you are analyzing the image as they come and then you make a decision, right? So have you thought about something in that direction? So now you detect and you move. But as humans, if we do it, we would correct if we see our hand is going away, right? So did you think of something like that?
So we did actually think of that, but we tried an implementation similar to that. What we did, since the arm was open when trying to pick it up by the camera because of how it's being positioned.
I see.
So because of that, we were able to have like a feedback loop that we have.
Okay, so if it were up to you, of course, here they have set up the arena. If it were up to you, what would be a good configuration of the camera such that you could pick up better?
So ideally it would be on top, but then at that position you wouldn't be able to detect the Aruko markers. So I think a better approach from at least my perspective would be a little more backward, like moving the camera a bit more backward so we have a more wider viewing range.
Okay.
Yes.
Okay.
Yes, sir. Yeah, yes, sir. That would actually help us. I would say the main challenge would be like calculating. Since now right now we have like a static camera, we know where it is at all times. Like we don't have to continuously always calculate what the difference is like from the camera link to the arm link. So if it was a moving camera, we would always have to calculate what is like the current camera location versus where the arm is and recheck that.
And then what would be the challenge if you put more cameras, for example? Will it help to solve your problem?
Yes, sir. In that configuration, all we would require is maybe one at the looking down,
yes,
and another one looking at maybe the rack.
Okay, okay. And also, I have noticed like you miss detecting all those yellow and red marks, right?
Yes.
So, what could be the reason for that? Like.
Yes, sir. So what was happening here is, if you notice, the bot was actually stopping near those shapes, but they were in our logs they were detecting the correct shape. So part of scoring for these is that you also have to publish what plant ID it is. So that is where we were facing the issue. Basically, the logic that we have implemented, it makes the robot stop once it detects the shape, and then it's supposed to wait for the odometry to stabilize a bit and then take that odometry and publish it. We are basically supposed to publish the bot's current location. So that is where it was facing the issue. It was not able to get a stable enough odometry because our tolerances were too tight, and because of that, since it was not getting a stable odometry, it was just moving on to the next shape and not publishing anything.
But did you face this issue while testing before?
Unfortunately, no, sir. Yesterday we had a good run where we were making all the detections.
So it's like most of the time there were like full detection and
Yes,
then,
yes. So we were facing like I think maybe 4 detections, and once in a while there was one false detection. But we were detecting most of the
So
time.
what's the key change in the environment you feel like, which lead to this?
Uh, Maybe so the configuration keeps changing every day, where the shapes are being placed.
Okay.
So maybe yesterday's configuration was more favorable to us, and today's was not.
So for example, your system is not like developed for dynamic like configuration, right?
It is developed for dynamic detection, sir.
But somehow it's calibrated for one kind of setup.
Yeah, so it also looks for the robot to be aligned towards the plant type, right? So let's say it's trying to go this way, but then the robot is this way. It's not properly aligned, so it will not be able to see what, will not be able to properly calculate the plant type. So it'll skip that, even though it is detecting it, it won't publish it because again we will have a false penalty for that. So that's why it won't publish it and it will go forward. So most of the time that is what happens. The bot is not aligned to the plant.
But what could be the approach if you want to correct this problem? What you would improve in your next run? Had we given you an next run?
So I would say since our plant, the shape detections were working perfectly well. The only thing is maybe work on the tolerances that we had and improve the plant ID logic. So the current plant ID logic isn't that dynamic and reliable enough. So which is what was causing a lot of problems for us.
So what was the logic exactly? Can you explain the algorithm part of it?
Yes, so we are basically taking the LiDAR scan, the scan data. We are driving around and we are using clustering and ransack to basically draw shapes, like draw lines. So whenever we see like an L shape or a line which has a diagonal shape, we basically detect those corners and classify them into either triangles or squares. And once that is done, those are detected as shapes, and then we get into the plant ID logic where we have basically defined that. So if it's at a certain XY coordinate, it's in lane number 1, lane 2 or lane 3, and then we compare with the current odometry and check whether we are in which lane to publish the plant ID. So that is where we were facing the issue.
Plant ID corresponds to some sector along that line.
It's basically like a plant ID 1 means the first plant. So the first plant has fertilizer required, or
So you have some amount of tolerance within that
yes,
grid.
yes, exactly, yes.
So you talked about your algorithm for laser-based shape detection.
Yes.
So is it a per scan analysis, or you can also accumulate those scans and say something over time?
It's a per scan analysis. We are not saving previous scans and confirming with them.
Would that help?
So
So that would help so that we don't do duplicate detections, because you would have seen that we would go towards this and we would come back there. So if we did not have the memory of the scans, we would detect it twice. So we do that. The duplicate detections are neglected.
So you do
Yeah, we do.
care for duplicate. What I was more looking at was just detecting an individual shape. So you pass next to that shape for a few seconds, right? So you make multiple measurements of that shape, of that plant. So do you use those multiple measurements to
yes,
filter?
so we have like a voting system in place where it I think checks 5 times if I'm not wrong, and if it's like we have like a percentage vote on 0 to 1 in decimal. So if it crosses a certain threshold, like it detects a square multiple times, only then it's detected as okay, this is actually a square, so that we can avoid detecting the edges of the arena as square, since they are having similar features.
I mean, we didn't see the detections from your console.
Yeah.
I'll believe whatever you say. Which were the ones which were detected and which was the ones which were not detected?
So we detected the square. We detected these two as well. So in the last row we weren't able to detect anything. But the issue was, even though we detected these 3 shapes, because of the plant ID logic error we were saying, I assume none of them were correct.
Okay, and what was the reason the same triangles were not detected in the last row?
So the alignment.
I see. Okay. Ah, okay.
Okay, thank you very much. Then
Thank you, sir.
So the next thing is once we are signed in, and we are going to start the first one. The run has started and they have moved both of them together. So the teammates for 1798 are Mangal Devanshu, Pavan Kumar, Deria and Patel Yashish. So the bot has reached the dock station and they are trying to load the fertilizer. They have aligned and dropped the fertilizer successfully. So the bot has not detected the square. They are moving towards the second lane. They have picked one fruit successfully. They are moving towards the second lane.
This plant is in bad condition. This plant needs fertilizer.
So they have made two false detections for both the plants. So there are like two conditions where they can be false. First is that they detected incorrectly, so the tolerance is out of the limits. So we have given a tolerance of around 0.6 where on either side of the plant. So they have to detect when they stop at the exactly, but we have given them a tolerance level. Yeah. Also one more thing is the odom should match with the position. They can't. So this is a false detection. So they were not able to pick the second fruit. I guess they are doing one. They are doing one more try for the fruit. The bot is entering back to the last lane and coming towards the dock station. The bot has stopped at the dock station. Stop the timer. So the run has ended. The time taken was 3 minutes 17 seconds. They have dropped one fruit. Yeah, it's a valid run. I guess the arm has stuck in a constant loop for the Good. Okay. Total parameters. So for this run, there are 3 correct fruit identifications, CBI, then there is 1 correct fertilizer detection, CFI, 1 bad fruit drop, CBD, fertilizer load, correct fertilizer load, 1 CFL, and lane navigation CLN 3 lanes, CPD we have 1 plant detection, and we have 3 false detection penalties, FDP. Bonus is 0. Now they will proceed to run 2. They have not detected the square. They have picked 1 bad fruit successfully, and the body is moving towards the second lane. They have dropped 1 fruit. They have detected 1 correctly and they have 1 penalty. One penalty, false detection penalty. Tolerance. नहीं उसमें पूरा फॉर्मेट फॉलो करना है एग्जैक्टली. Plant ID, ODOM, X, Y, Z. They have missed one triangle. They have dropped two fruits successfully and approaching for the third one. They have missed the third fruit. Stop. The bot has stopped again at the dock station. The arm is trying the third fruit again. It has picked the third fruit successfully. The bot is waiting till the arm completes the task. They have dropped all three fruits. Stop, stop. The arm has gone into singularity. This is end of the run too. The time taken is 4 minutes 2 seconds and the parameters. So the parameters for this run: 3 correct bad fruit identification CBI 3, 3 correct bad fruit drop CBD 3, CFI is 1 fertilizer identification, loading is 1 CFL, correct plant detection 1, lane navigation 3 CLN, false detection penalty is 1, and yeah, bonus is 0 and collision penalty is 0. So now we'll move to the Viva of the team.
Yeah, hi. So, you
Hello.
yes. Hi. So can you hear me?
Yeah.
Yeah. So while picking up in the next trial, you succeeded, right? But the point is, like in both trial, towards the end, you failed. Your robot, like, or your system failed to pick up the fertilizer and put it up there. So can you explain the reason why this happened?
See. Yeah. Yeah, okay. So basically the fertilizer was, the arm was not able to pick up the fertilizer because it was stuck in the fruit picking loop in the first run. So in previous run, our arm, our script for the fruit pickup was working very well and it was able to do all 3 fruits. So we did not implement the safety measure of if the dock, if the e-bot proceeds to the dock and he should pause the task and just pick up the fertilizer. That part was missing from our side. But in the last run, what happened, I think we have set dynamic transforms in the space of the arm. So this time I don't know why it went into singularity, but in the other run it was successfully able to pick up the fertilizer. What is our process is first we park the arm near the e-bot, like in the right side of the e-bot, so it can scan the Arupo marker that is on the e-bot as well as fertilizer. After that, it confirms the transform. It proceeds to pick up the fertilizer. So it can only detect the front edge and the edge there. So it can only detect a corner and the base behind the shape, right? So we implemented that in our algorithm, and when it detected that, it basically stopped during that. We tried to improve the tolerance, but then it sometimes missed the fertilizer and do not, it missed the shape and do not stop at that point. So also regarding the false detection, you can see there is some gap between the racks of the plants, right? So in that gap, the LiDAR actually detects a corner. So sometimes in the first run, it actually detected that corner and published bad health. So yeah, that was the issue.
So is it like so this tolerance issue would be faced even during your runs, right? Like during your trial runs, or
Yeah.
is it like the shape has changed because of that? This tolerance has come into the picture.
No, no. Tolerance was always an issue from our side. We tried multiple algorithms, like we tried to implement specific waypoints it should stop,
Okay.
but still some tolerance issues were there. Okay. Thank you.
The next team is team 2093, and they are about to start their first run. The team is about to start their run. Names. So the team 2093 consists of 4 members. Sai Satya Prakash, Kamal Kumar, Abhijit Sahu and Ansika Priyadarshini. The run has started. The bot has stopped at a dock position. The arm is loading the fertilizer.
Very barely stay by the generation.
The arm has gone into singularity. Run. चल रहा है run. The arm has been resetted. Stop. Stop. Timer stop. Second run. Second run. So the first run has ended. So the arm was not able to load the fertilizer and it went into singularity. The time is 1 minute 35 and it's not a valid run.
Okay. I'll show you our video. one video which will show.
और एक बार करो और एक आर्म रीसेट
Payload is 1.8 times robot. So here it is at the first floor, it can go to ground floor, pick up. So this can interact with roads, everything autonomously. So this is very driven. No, it is independent differential driving.
Reset.
Payload up to 2 tons. Now we have one variant is this. Another is a smaller variant is up to 400 kg. We support up to 2 tons. Then we have a pallet machine. So autonomous forklifts, we have automated that. And then we have an outdoor tugger for outdoor applications. So this goes to lift automatic. And then most of our clients include Volvo, Toyota, Picard, Daikin, mostly all Fortune 500 companies. Also, we have around 30-40 clients now. So,
so yeah, we have given the map of the arena. They can, if they wish, they can use, but it's not a compulsion. But they have the map of the arena. Yeah. Oh no, so we have prohibited from them to use like NAV2 packages. So all the navigation is done by them. There is no, NAV2 is not allowed. For ARM also there is no movie.
We are making around 8 to 9 robots per month. So far we have deployed 100 plus robots across India for this. This is only the case that Daikin.
No, we have given the map by doing basically basic mapping, but they are not allowed to use the SLAM. We have given the map for like to get the positions of the lanes or because arena has changed a bit from that room. So for the exact dimensions, we have given them. And 1 week of practice in this same arena. So the team is ready for the second run.
Different cobots also. This UR, and we have done it with this. We have done it first. This is the first year we did it here.
The timer starts now.
First year we did it here. So then that time we had a team here and then our team goes up here. This with respect to one of robot on top, so we do pick and place operations. Now we are doing like multiple operations in industries to pick and place scan.
One collision penalty.
Like different robots on top. With all
the arm is trying to load the fertilizer.
In a smaller base.
They have loaded it successfully and it's a valid run. One correct plan detection. They have navigated one lane and they are entering the second lane.
Okay.
They have entered the third lane. The bot is trying to move. The run has ended. Stop. Time is 2 minutes 36 seconds. So the parameters are 3 lanes, 2 lanes correctly navigated, 1 correct plant detection, then 3 correct bad soil identification, and 1 fertilizer load, 1 correct fertilizer identification. 0 bonus and no fall detection penalties, 1 collision penalty for the dog station.
Maybe I so what was
So I think what happened is using a LiDAR calibration to make sure. See, the bot, they are manually docking the bot in the home position and restarting the LiDAR every time. So if it's like a little bit toward that side and the LiDAR starts there, it will, and odom starts there, it will consider that part as center, then adds set so that interference with the LiDAR calibration is a little off and the offset is more or less something like that. That's why the bot couldn't properly identify the lanes.
see, for example, you have hard coded so much things there. That is the
No,
problem.
actually I tried to not hard code it. If I have hard coded it, let's see, if I am saying the bot to go to that side 2 meters, that would be hard coding. But if the bot starts from a little to the side, the odometer will be 0.
And then you have
They are the waypoint, and the bots its correction and difference between that position and aligns uses trigonometry to find the angle, aligns toward that direction and moves straight toward that direction until it reaches a certain tolerance. So that's the navigation logic.
So tell something about how are you detecting your fruits and what was the problem that occurred here, that the fruits were not, the plant health was not getting detected.
Actually, we are using a Hop transform for the safe detection. We are using a 180-degree LiDAR, so we can only see one edge of the shape. So we are using Hop transform to plot lines. First we are filtering the LiDAR data, then we are using probabilistic Hop transform to plot the lines. Then we check the slope of the line. We assume that for rectangles the slope will be more towards 0. So we give a like 0 to 2 or 3. Between that, it detects a square. After detecting, it moves a certain distance forward, stops right in front of the shape, and publishes the odometry data and the bad fruit detection. Similarly, for triangles, we check the slope of the line and use that to detect the plants.
So what went wrong with it? Because you were not able to detect, you had one collision,
Yes.
and then you didn't saw any detection of the shapes.
Sir, we did one detection. Rest of the detections were not available, maybe due to the, like I said, the drift of odometry. The calibration we were using may be due to varying lighting conditions. The lighter calibration may have drifted. So it's like it should have come a little closer towards the triangular shapes, because in probabilistic Hopf transform we gave the number of points it needs to detect a line and the length of line also. So those parameters would have varied if the bot were to go toward that side.
So given a chance to improve, what would you do to improve that calibration which you are saying?
Yes.
Like, because you are suspecting light is going to
Yes.
impact, right? So how you will improve that?
We can improve that by taking data from various time of the day, like in various lighting conditions. If we take different data, we only tested it in the night time. We didn't have a chance to test it in the daytime. So maybe that's why it drifted.
Laser won't affect with light. Physics will not affect.
Then maybe due to, because we are checking the distance from that boundary to this boundary, so maybe that could have also affected. So we are not sure, but I am pretty sure that that offset set the navigation in the wrong path. So that's where all the problems arise. Like the arm went into singularity, and all problems arise from there also.
So you said like you are not allowed to use the code, right? So
Yes.
some existing code you are not allowed to use for navigation.
Yes.
But the point is like, did you go through some existing methods so that you can apply some like solid methods, like scientific method which are used for navigation tasks?
One of the methods is SLAM. You should know.
Yeah.
It's simultaneous localization and navigation. It uses the same concept. It takes the LiDAR data and localizes the bot. It doesn't singularly depend on the odometry. I have tried implementing that data in the LiDAR calibration I mentioned in the starting.
Okay.
I got the idea from there and tried to implement in a small scale. So yes, I have tried to implement some of those.
Okay, and then did you implement that, the SLAM method
Yes,
here?
I am using the LiDAR to scan the both boundaries, this side and that side boundary,
Okay.
to make sure that where the bot is. I am not solely believing the odometry data. If you reset the bot at the starting of there, the odometry will say that's the 0 0 position. But I am not solely believing that. I am using the both side of the boundary to make sure that the bot is in the center. If it's toward that side, then the odometer will get some offsets added. So
Okay.
it's kind of slam in
Yeah,
a
but-
small version.
But still, like it didn't work. So that's the point.
I have to calibrate it more because I only implemented that here. So I have to calibrate it more.
So let's say you don't have the opportunity to know your environment you'll operate in. You
Yes.
don't have the opportunity to calibrate. What
Yes.
would you do then?
Uh, if
Assume
I,
you know nothing about this. I'll completely change this.
Yes.
What would be a way in which it would still work?
if you completely change
Yeah.
the arena
Yeah.
and
The size, the orientation, or whatever.
we have to go to the particular points we have to go to the dog point. We know the position of dog point. Would that still be available, or
Yes, yes.
that would be still,
Yes.
but the obstacle positions will be
Yes.
changed. Then
The
I
arena
think-
shape could also change. It might not be a rectangle, but maybe some other shape, a circle or some other shape.
so for that situation, we have to use the LiDAR to see the obstacles right ahead of you, and I will similarly currently the bot is rotating it towards the whole goal position and moving straight towards it. In that scenario, I will imagine something like I will use the LiDAR data to see if there is any obstacles in front of me. If there is an obstacle, I will reroute the path dynamically. If like the obstacle is to the right side of the like my intended path, then I will turn left, and if it's to the left, then I will turn right.
Yes.
And similar, if I continue in the similar fashion, I think the bot will reach towards the goal, even without a predefined map.
Okay, one follow-up on this. So this is how you will deal with obstacles and how you will go around it. So this is in a way a local understanding of your area.
Yes.
Let's say if I don't tell you, I pick up the robot and put it at a different spot in the arena.
Yes.
Same arena, let's say it's the same arena.
Yes.
I don't tell you that I'm doing this, but the robot is picked up. This is called the kidnapped robot problem. Would your approach work, the current one that you implemented in a kidnapped robot scenario?
Yes, as long as I properly calibrate that LiDAR calibration part in various like conditions.
So you need to see the two edges always.
Yes.
So what happens when you're in the lane there?
Yes.
When you're in between the lane there?
Between the lanes. In between the lanes, it will still detect the lane walls and position itself in between the both lanes. That can work.
Okay, thanks.
Okay, thank you, sir. Thank you.
The next team is team 2345 from college IIT Dhanbad. The team members are Pratik Basu, Manaf Tikadar, Jayjeet Mandal and Tirankur Bera. So they are about to start their run one. The run has started. The arm is moving currently. They have attached the fertilizer successfully. They have calibrated the message. They have picked the fertilizer and waiting. The bot has started to move. Thank you. Thank you. The bot is moving towards the dog station. The bot has stopped and waiting for the loading. The arm is approaching the bot. They have loaded it successfully. Approaching for the fruits, and the bot is moving towards lane 2. They have missed one detection. They have picked one fruit. The bot is approaching the second lane. They have dropped one fruit. There is one false detection penalty. Ant ID. The bot is in the third lane. They have picked one more fruit and dropped it. One correct plant detection.
Detection is there.
They have picked the third fruit also and moving towards the dog station again. They have dropped all three fruits successfully. The arm is approaching for unloading. Stop the run. The arm was unable to unload. Time taken is 4 minutes 16 seconds. No collision penalty, right? No. No, it was when he moved. Got it. Collision नहीं हुआ ना?
You need a feedback mechanism, some kind of sensing.
Like you said,
पीछे पीछे.
no coordination. In some sense, there is little coordination in the sense that it does its job, as long as it is not visited inside.
Arm reset. They did one detection, right? One correct detection.
Yeah, somewhat time is the part where
These are still like 3 seconds or 30.
I don't find it the fact that it's moving at all is a 5. That's why my fitness is 5 star everybody.
Now they will have the second run. Arm reset.
They have this precise scoring and look at the stuff. Yeah, understand. I don't do so much weightage to have.
I really used to do this for
Decent. They are able to do everything, right? Only unloading, not. And detection is.
But here only one person is answering it.
There are 2 more teams.
I'm sure they're probably putting forward purpose.
We can ask others also.
It is small time till
Back there
in the buzzer. I think they have been mentoring continuously. They know. Another thing like you said, I think at this scale we can do it, but if this has to become 10 times, I don't think the current mechanism would work. It's already taking days and months of work to
Actually, the problem with the statement is like they get very limited time compared to other teams.
the remote work.
Remote work, and then they get a very limited slot. So
That's quite some.
Chalu hai.
I would
Reset.
expect some teams not to do it from the start.
maybe that has happened years back. Now at least team is like the team.
The team is ready for the second
People
run.
organizing this team is making the people to work. They train them, coach them. Because that was the last 2 years feedback on this team, like basically to improve the, at least to show when you are demonstrating something, it has to work.
The time has started. They do the waiting thing. IIT. The arm approaching the fertilizer. Okay.
That is the way like you
Right.
can show difference.
10 minutes. They have picked the fertilizer
That's a bad
and the bot has started to move towards the drop station.
communication between the arm and
The bot has stopped at the dock station. They have loaded the fertilizer successfully. One correct plant detection. Arm has gone into protective stop. No. One false detection. The bot is moving towards the third lane.
probably they would have some mechanism to come out of it.
Two correct detections. Stop the run. The arm. The time is 3 minutes 51 seconds. Parameter.
This run will complete.
So the parameter for this run, CBI 3,
But this navigation
CFI 1, CFL 1, correct plant detection 2, CLN 3, and 1 for false detection penalty.
they detected everything. Yes.
Almost like good detections, there are two false detections. Nothing pick up was also.
Okay, so So what happened in your second run? Like in your first run, you were able to pick up fruit. Your robot was also moving fine. So what was the issue that happened that your gripper was not working and fruit pickup?
So what I think that happened in the second run is that the three fruits that were there, that the detection was wrong. Like it detected some other part of the, like it published a different TF and the arm was going to trying to go there and it collided, so the arm stopped. The plant detection was wrong.
So the fruit detection.
Yes, sorry, the fruit detection.
So what you would do to mitigate this if you had to do this again? Like why it was like your arm was stuck, so could you come back out of that loop? Like can you detect that your arm is stuck and you can start again?
No, because the arms self collided, it was dropped from that their side, the operator side. So we didn't have control over that after that.
So it's the hardware that is
Yeah.
Was there something you would have done to stop it from colliding in the first place?
Maybe we could have like got the joint states and saw like if the joints are in certain alignment, or it was trying to go, the angles between them were becoming closer and closer, then we could have send a command to go make it go to the home position or the initial state.
Some safety barrier.
Yeah.
So one more question is about when you started the robot, your arm was working on picking the fertilizer,
Yes,
but
sir.
your robot was stationary.
Yes.
What was the reason for this design?
So we were ensuring that the fertilizer, the arm first picks up the fertilizer and then the bot starts, or else if the bot reaches before the fertilizer, it could reach the fertilizer, then it would not send the signal, it would not, the arm would not receive the signal that the bot has reached, then it would be stuck in that position.
But could
Like-
that be done? Like can you like improve
Yeah, yes,
on
sir.
that?
We could have done.
Because you could save a lot of your time
Yeah.
if you are doing a concurrent task.
Yeah, like that happened in the second time. The bot reached before the arm could complete the fruit pick and place. So that's why the arm stopped and didn't do the unloading portion.
So had you to do that particular task where your bot is performing independent of your arm, like at least the starting navigation it can start.
Yeah,
So
we-
what kind of changes you have to do in your on
Just
your
like
side?
this, that when the arm reaches for the fertilizer, then or the like the bot reaches the first waypoint, then the arm could start like this. Could have done. Like with, yeah.
You know the concept of state machines.
No,
Like-
sir. Anyone state machines?
So, for example, what would be a reasonable state machine for this arena? So, for this tasks that you're doing, what would be the things that you would consider in that state machine? Because currently your things don't communicate with each other intelligently. They don't really know what the state the other person is in, right? So, how would you design a state machine for this task? Sorry? Mm-hmm. Yeah, so this is more about communicating. State machine is knowing what every individual agent in your system is currently up to. So, for example, the deadlock that you're having can be solved efficiently if you maintain arm is currently in the picking fruits domain. The bot is in lane 3, things like this. Things which give you a higher level understanding of what's happening, which you can then use to plan properly. So currently it's reactive, but you can also plan a lot of these things.
So the next team is 3578 from Shantilal Shah Engineering College. The team members are Raghav, Ashish Kumar, Aman Ratan Lal and Harshil. So they are ready to start their run 1. The timer starts now. The bot has stopped at a dock station. The arm is approaching towards the fertilizer. The fertilizer can has dropped. It's not a valid run. Stop the run. It's not a valid run as they drop the fertilizer. Now we'll have the second run for team. जल्दी हो जाए, टाइम बच गया. So we are ready to start the second run. The timer has started. The bot has stopped at the dock station. They have loaded it successfully this run. One correct detection.
e-bot. For that I use net-based topic, if the changes occur in the magnetic force, some units, then it's drop the e-bots on the e-bots. So sir, first time changes in the net-based topic magnetic force, therefore they stop it
No, but,
drop at the
every point. For example, when your robot try to pick something, thanks. So when your robot try to pick this, so it stop at this point, it stop at this point, it stop at this point.
Okay.
So
Between the phase transition, we seen that if we suddenly change the transition, so we face some other kind of.
no, I understand you do not have to suddenly change, but why so long? You have to, because it look considerably long, right? So it paused there at every point, and it took a long pause.
Long
So
for the orientation, if you are going to be directly to the orientation, when I try to going to directly oriented in the proper way that we can pick up the fruit, fertilizer. The fertilizer, I will be from my side, I will not handle these things orientation angle. So that I going to be 10 centimeter above, and after that I adjusting the angle for the proper orientation of arm, wrist 2 and wrist 2, so you can pick up the arm.
yeah, that's all right, but it still doesn't answer my question. Like why? What's the time pause there, right? So why it stopped there? So that's
Actually, sir, we are in the first time in robotics team, so sometimes we are little, you know, do not understand the properly.
So you didn't.
It's first time, okay, and he
For
did
the
it.
long way, he adjusting the edges, from the proper orientation. He checking the orientation will be proper to pick up or not. If it not, then it try to adjust the wrist 3 and wrist 1 to adjust it. If you see in the, they move little bit for the pickup, the face to face.
So I think what you meant to say is that you have some control logic written
yes.
for controlling the arm,
Yes.
which is doing some kind of if-else logic.
If there is in the orientation or not checking that, if not, then it's going to be adjust this orientation. Checking the error, how much errors are there.
Just a comment on this sensor in robotics. There's something called as visual servoing. You don't need to do if-else things. So you have a desired orientation and you can kind of do it continuously.
We tried in some time, directly going to that orientation. It's going to another direction. So for the this session, I decided
for something slow and
for this.
So maybe you can maybe comment a little bit of what was your strategy for, we didn't see it, but what will have been your strategy to detect the blocks, the plants, yeah, so what the shapes?
So what basically we did, we first tried to find out the ball, the tracks we considered them as ball. We are fitting all the points that we are getting from the radar as a wall, and whatever the points are basically not fit in the point and towards the our board. So we are considering them as a cluster. So we are neglecting every point that is not between the wall and the keyboard. So it basically solves the noise problem. And whatever the cluster we found, we apply the Rankine logics and we find the angle between the ball and the lines that we detect. So basically it solves all the problem. If it is a triangle, it's going to be less than 90 degree, or if it is a rectangle, it's going to be 90 degree. So this solves the problem of detecting. And for the dock station, we haven't hard coded the values. It detecting either rectangle, either triangle. But if it is in LAN 1 and toward that wall, so it's going to be the dock station. So
did you, in your trial runs, did you come across some cases in which this logic failed?
Yes, we did some cases. Sometimes it fails near the corners. It detected very good at that point, planned. But if the e-bot is coming towards this LAN, then if it directly enters the LAN, so it misunderstands the corners of the tracks and the shape. So sometimes it publishes, but we have placed a boundary here, so it starts the detection when it enters LAN properly.
So last question from my side, what would be a way to make this more robust, your detection mechanism? What would be just some ideas that you could do?
We haven't thought about very much. I don't know. Sorry. Yeah, sorry. We can go. So, is there any other questions you would like to ask? Okay.
Do the reader and then give us some questions.
So we'll have the run to of team again due to the light issue. The team is ready to start the run. Start the timer. The bot has stopped at a dock position. What do you think? Will it come? Sometimes invalid. Stop. Not stop. क्या करना है? Invalid रन या valid रन? Three correct detections. One, they have dropped one fruit. Four correct detections. 5 correct detections. Luck, bad luck. We'll see. I don't know. They have picked the third fruit also. Oh no, we'll give them or not? That is very tough. They have dropped all 3 fruits. अरे यार क्या सर ने बोला देखना है कि सर को होता है कि फिर उठा लिया नहीं नहीं वो ना हो गया I think they attend. नहीं नहीं रोकना अभी आएगा वो I don't know. The problem is they dropped, you know. Good. Huh? According to the rules, it's email. गिर गया ना वो ड्रॉप होने के बाद स्टॉप Time is 7 minutes 1 second. Parameters CBI 3, bad fruit drop 3, fertilizer identification 1, loading 0, unloading 1, detection is 5, lane navigation 3. No penalties.
I don't dislike the idea of straight line and all those work for the detection.
It's not blindly following the straight line, it's detecting the object nearby and drifting little bit from the straight line to avoid them. So that you can see when it was moving, it was drifting to dodge the lines. And for the detection part, we actually using the both side. We are cutting the a sector of the lidar for the left and right part, and we are applying our cell detection only on this part. And we have a voting system so that whatever shape has maximum vote will consider the legitimate, and it will publish that part. So that's why that was so accurate when it was following the left backward
Good job.
Any other follow-up questions?
I think we are running out of time.
Thank you.
The next team is team 4474 from Rajiv Gandhi University of Knowledge Technologies. The team members are Badampudi Salim, Taik, Tatikonda Venkata, Dangeti Pavan, Pati Bandla Navya. They are going to start their run one. It's already on. So this is the last team for the day for Krishi Cobot.
Original mode. Original mode.
Their first task was on their publication before, right? No, publication.
Was okay. No, sorry, image processing was done. It's difficult to guess image processing was.
They missed the detections.
Yeah, they missed.
2093, right?
No, this is 2345.
Yeah, they missed the detection.
They have done better detection. They have missed.
Their arm was quite bad, right?
Yeah.
Oh, yeah. The team is ready to start the run. The timer has started. The arm has reached the dock station. The arm has attached the fertilizer.
Will it be alright, like at 12 if we meet?
Yeah.
Okay, so. Okay. And when you will be today?
The team has placed the fertilizer.
In the afternoon, I have a like lab. I'll be in the lab. So, or will it? After 5, I have some meeting with my team.
One correct
Yeah,
detection.
5:15 will be alright. So if you meet. Or how about Monday? Will it be alright? So if we are going anyway to we are going to meet, right?
The bot is entering the second lane.
Okay.
They have attached one fruit.
Okay. Let's we can discuss that. And I'm sorry for now.
One false detection. Two false detections. They have dropped one fruit correctly.
Detected, but it said false, so I'm not sure for what reason.
One corrected, one false.
Both false.
They have attached the second fruit.
Yeah.
Red was correct. Yellow one was.
Two correct detections.
Detection.
Three correct detections, and they have dropped two fruits. They have picked the third fruit.
This is the last one, right? The first one.
They did everything except that is the first.
They have dropped the third fruit, and the bot is coming for the dog station.
That's it. It's easy to pick.
Yeah.
It's still good.
But it was the time, right?
Yeah.
They have unloaded the fertilizer, and the e-bot is coming back to the home position.
I guess this one.
This is the
The timer stops. So the no, shape decision is not full. Right? So the parameters: 3 correct fruit identification, 3 correct bad fruit drop, 1 correct fertilizer identification, 1 loading, 1 unloading, and 3 correct detections for the plant, 3 lane navigations, 2 false detection penalties for the plants, and no bonus. The time is 4 minutes 23 seconds.
The detection was except the slow performance, I would say task-wise it is still competition with full accuracy.
So the team will have the final run, and this is the final run of the Krishi Cobot.
we are not putting it to the problem. It's meant to be. And this is before.
That's great. so we'll keep in touch. Yeah. Yeah, that's no, I mean,
They finished it.
you have a card. You have a card.
Huh?
Okay. Okay, sure. Oh, okay.
तो शायद कुछ दे देंगे बोनस अच्छा लगा The run has started.
So what's the number? 87. Yeah. 549.
733. Can you give a ring?
Yeah. The network is very bad here. Yeah.
The bot has approached the dock station and the arm is trying to load the fertilizer.
But what's your name? Muthu. To both robotics, right? Yeah, electrical, yeah. I spell it.
They have loaded the fertilizer successfully. One correct detection.
Okay. Thanks. Automotive control. So I have control watching
The arm is moving towards the bad fruit. They have picked one fruit. Two correct detections. One false detection. They have dropped one fruit and going for the second. They have picked the second fruit and dropping it. Three correct detections. Four correct detections.
Where I've seen like this, they put this fertilizer and like it's very risky.
I think they found that there's no point during this year.
Yeah, I guess risky, but
they are waiting for a minute, or else we will end the run.
The previous run will be anyway better. Previous run will have 2 points.
It will be close. I think they might have some discussion about whether that's valid or not. Let me leave it to them.
Oh, but I guess it would be fair if they consider that this show that they.
I mean, I guess like system-wise, there's probably a little bit more robust,
Yeah.
especially on the arm side.
And the task-wise, the other
The
one.
detections they did very well. I don't know
Got
what
it.
they did. There's some time out. I guess anyways, I think our part is so small.
Run it.
So they-
Stop the timer. The run has ended.
There was no correct detection.
There was one incorrect and everything else was correct.
One incorrect and every else is correct.
Which one?
I think this is red one. It's also detected as a triangle.
I think in previous one also it is similar. There are 2 incorrects. And rest one correct.
This is kind of a challenge here because I guess అది దీన్ని ఆపచ్చు Yeah. So, can you explain like what happened towards the end? Like, because everything was going nicely in terms of its motions and navigation, but towards the end, why it stuck?
Actually, it's a very good question that you got like that. But I think the most probable, and we cannot say anything with the terminal like timeout to get us in our control. But I think the most probable reason may be the net print threshold. Most probably, but we hadn't told you.
Okay, so this happened. This happened only this time. So
Yeah, the first time also it went well.
So you decided to put the fertilizer box upright. Was there a reason for that?
Everyone tried, sir, but sometimes it worked, like picking the fertilizer and all. Sometimes it went into protective stop, like the arm is, when picking up the fertilizer, it was pushing the fertilizer too long, so it went into protective stop. So we thought different, and we asked the team members whether there will be a Roku marker on both sides. So we come up with an idea, and actually, so this we did implemented this in the last run only, like last practice slot we implemented yesterday night.
I see. So it was the last one. Okay, maybe one question from me is on the LiDAR-based detection bit. So I think it failed once, I guess. What's the algorithm behind, and what happened in that case?
The actually for the detection of shapes. I think the probable mistake there was the shapes are not exactly aligned. I mean the square is a bit different yesterday. So I would assume it is having the when they different. So and the square is a bit tilted. I mean we kept it like a ratio per square, like it will measure the length of this side and that side, and according to that, if the ratio is greater than 0.85, it will detect that as a square. There, I think the threshold maybe it is around 84 or 83, so it has not detected it as a square.
We also do something to make it robust for multiple detections. So you detect multiple times.
Yes, sir. So for the same place, there won't be any detections until like 10 seconds. Once it will reject it. So the case is like for one plant there will be only one shape. So that's why we time limit to stop detection after detecting one shape.
Okay, if you would have given a chance, which would have been improved better? Like, what would have been a better, like, if you would have given another chance, which module would have been improved to the next level?
So for our
Maybe which module you feel like you would have done better? Maybe you have multiple models like pattern recognition of these things, marker detection, navigation, image detection. So which would be your best, or which you feel like you are a little low? What would be the next step to that?
yeah, obviously the shape detection part we can improve a little more. And that's it, sir. Everything is fine.
What is your current shape detection algorithm and what you wish to do?
There is a limit to it, so where maybe it will be tested.
So basically increasing a threshold may not be your right approach, where we have to go for some more, little more robust approach, because today 8.5 did not work, tomorrow 8.0 can also be. Thank you. All was good. Everything.
Anything like you would like to say to sum up? I'll ask each of you basically.
It was a very nice. The thing is like it works, right? So the point is like you
Point 0.75 it will fail in the other cases. So you have to think about more in a way that is more robust. Create a solution which is safe, fail safe. Like if it is not working, like try to get maybe multiple readings, do averaging or do some techniques which can help you improve your algorithms. But overall, it was a very good attempt and well done. You are already a winner. Whether you get first place or fifth place doesn't matter. You have learnt a lot of things in this process, and what when we started, eYantra is engineering a better tomorrow. So we want you guys to go ahead in your college, help your juniors, help your future batches to like participate, do better things, do engineering in a better way, and make our country proud. सर आपसे सीखा है सर.
Little token. We don't give useless plaques and all that, by the way. We give you food.
Oh, thanks.
Right, so anyway, thank you very much. So we don't give useless things like plaques and things that just sit there on the shelf. These are things, organic food of various kinds. There's something interesting here. There's organic jaggery of the finest variety made by an IIT alumnus who used his PhD in thermodynamics and his PhD in melting point of glass to use that same knowledge in making jaggery, which is the best that you can get. And he's got a plant in Pune, and his name is Dr. Vishal Sardesh Pandey. Right, so there's some technological artifacts in the food also. So thank you very much. All the best. God bless. Jai Hind. See you.
Thank you very much for this.
So good.
मैं क्या बोल रहा हूँ, ये भी चाहिए उस पेपर
फोटो लेकर तुम्हारे पास रखना बाकी सब चीज दोनों के सब A to Z everything like if you can put everything put it sure thanks Jason great guys yeah and last but not the least yeah last but not the least